Have you ever looked at a perfectly black shirt or something and realized it's not truly black? It always has that little bit of a sheen to it.
Oh, absolutely. A little reflection.
Right. Well, today we're doing a deep dive into materials that make every other black you've ever seen look like a dusty shade of gray.
We're talking about ultra black material.
Exactly. And the whole mission here is to understand these substances engineered not with dye, but with their actual physical structure at the nanoscale to just eat light. We want to figure out what the future holds for objects that look like literal holes in the universe.
And to really get into that, you have to start with the most famous one, Vantablack.
Right. The one everyone has seen in videos.
That's the one. The name itself is actually an acronym. It stands for Vertically Aligned Nanotube Arrays. So you can picture it like a microscopic forest of incredibly tiny carbon tubes.
A forest. Okay.
And the science here is, well, just spectacular. Vantablack absorbs up to 99.965% of visible light.
That number is just staggering.
It is. When light hits that nanotube forest, it gets trapped. It bounces between the tubes, and it just deflects around until it eventually dissipates as heat.
So it just vanishes.
Pretty much. The result is this visual magic. You can coat a three-dimensional object in it, and it will look perfectly flat, like an eerie abyss with no features at all.
That sounds perfect for, say, reducing stray light in a telescope. But the way you describe it, these fragile carbon tubes, it sounds incredibly delicate. Is this just an industrial novelty, or are we seeing real-world uses?
Well, for now, it's mostly a high-stakes, very specialized tool. It's phenomenal for things like space and defense.
For noise reduction and sensors.
Exactly. Improving sensitive telescopes, making infrared cameras better. But you're right, the delicacy is the issue. And that's precisely why the next wave of innovation has focused on finding more robust, more scalable alternatives.
So if the challenge is making it tough and affordable, how on earth did researchers get almost the same result using something as, well, as common as fabric?
That takes us to this fantastic breakthrough from Cornell University. They made the blackest fabric on record. It absorbs 99.87% of light.
Almost the same as Vantablack.
So close.
Yeah.
And they started with merino wool, dyed it with a polymer, and then, this is the clever part, they used a plasma chamber to etch the surface.
Plasma on wool.
I know, it sounds wild, but this process creates these tiny light-trapping structures they call nanofibrils. Think of them like tiny bundled hairs all standing up on the fibers.
And what's really cool here, I think, is that the whole idea came from nature, right? From
So
a bird.
Yes, the magnificent rifle bird. The male bird uses structurally black feathers to create this incredible contrast with its shiny iridescent chest. It's all about standing out.
And the engineered fabric actually does it better than the bird, doesn't it?
It does. It maintains that absorption even when you look at it from really sharp angles, which is a huge advantage. And this focus on sustainable structure, it goes beyond just textiles.
You mean like that super black wood?
Exactly. Nixylon. It's a wood material that absorbs 99.3% of light. And it was discovered almost by accident, just by using plasma gas on basswood.
So what's the big appeal there? Why black wood?
Well, it's stiff, it's lightweight, and it uses a renewable source basswood. So this positions it as a really sustainable replacement for rare, dense woods like ebony, or even for black gemstones like onyx in some luxury items.
Wow. But achieving that kind of absorption, whether with nanotubes or plasma, I mean, that requires incredibly precise, advanced technical processes.
Oh, absolutely not something you can do in your garage.
And, when you're dealing with advanced technical processes like that, whether it's nanoscale tech or modern data solutions, expertise is essential. This deep dive is sponsored by Embersilk. If you need help with complex AI training, automation, integration, or software development, check out embersilk.com for all your AI needs. They can help you uncover where agents could make the most impact for your business.
But if you're looking at the bigger picture, the really durable future for these materials might come from copying nature's ultimate blueprint.
Not the bird this time.
No, we're talking deep-sea fish. Like the anglerfish, odioids, they are the gold standard. They reflect only about 0.044% of light.
0.044. That's practically nothing. And they're not using delicate carbon tubes, are they? What's their secret?
It's all about melanin, the same pigment in our skin. Their blackness comes from an incredibly dense, highly structured layer of these pigment packets called melanosomes.
So it's the arrangement that matters.
It's all about the arrangement. They're packed so tightly and perfectly that any light that enters the layer is just scattered sideways and immediately absorbed.
Okay, so that's the holy grail then. Instead of some complex, fragile coating process, you could mimic this natural pigment structure.
Exactly. It promises the ability to create ultra-black materials that are robust, durable, and maybe even sprayable like paint. That opens up the mass market potential that something like Vantablack just can't reach.
That's the real game changer.
It is. This progress shows the true power of biomimicry. Engineering how we absorb light doesn't just let us see deeper into space with better sensors, it also guides us to creating materials that are both strong and sustainable. It really proves that nature often holds the blueprints for our next great leap.
That ability to just unlock nature's own efficiency and then turn it into durable technology for everyone is incredibly exciting. If you enjoyed this deep dive, please subscribe to the show. Hey, leave us a 5-star review if you can. It really does help get the word out. Thanks for tuning in.